Hey everyone! Today we are solving a calculus problem about finding the volume of a solid generated by rotating a shaded region around the y-axis. We'll break this down into 3 simple steps: finding the constants k and m, setting up our integral, and solving for the volume. First, we need the exact equation for our parabola. We are given 2 points, point A 1 and 6, and point B 2 and 18. Let's plug these into our function y equal kx² + m to create a system of equations. For point A, 6 equal k times 1 squared plus m. This results in 6 equal k plus m. For point B, 18 equal k times 2 squared plus m. This results in 18 equal 4 k plus m. Now, subtract the first equation from the second to cancel out m. 4k plus m minus the quantity k plus m equal 18 minus 6. Therefore, k equal 4. Now plug the value of k back into the first equation we found from point A. 6 equal 4 plus m, so m equal 2. Our function is y equal 4x² + 2. Now let's set up the volume integral. Since we are rotating around the y-axis, we need to integrate with respect to y. This means 2 things. First, our limits of integration must be y values. Second, our function must be in terms of y. Looking at the given points a and b, we know that our limits will be between y equals 6 and y equal 18. Now let's start rewriting our function. Y equal 4x² + 2. First, let's isolate the term with the x so we can subtract 2 from both sides. Now we have y minus 2 equal 4x². Next, we need x² by itself, so we divide the entire left side by 4. This gives us x² equal y minus 2 all over 4. One of the most common questions students ask is, why didn't we take the square root? Don't we need to solve for x? Let's look at why stopping at x² is actually a calculus pro tip. When we rotate a region around the y-axis, we are essentially stacking up thousands of tiny, thin circular disks. The area of just one of those circles is pi times r². In our graph, the radius is the horizontal distance from the y-axis out to the curve. That horizontal distance from the y-axis is simply the x-coordinate of the function. So the area of a single slice is pi times x². Look closely at the volume formula. Volume equal pi times the integral of x² dy. It doesn't ask for x, it specifically asks for x². By stopping at x² equal y minus 2 all over 4, you save yourself an extra step and avoid the risk of making a mistake with radicals. So, our integral is volume equal pi times the integral from 6 to 18 of y minus 2 all over 4 dy. Let's solve our integral. Volume equal pi times the integral from 6 to 18 of y minus 2 all over 4 dy. We can pull the constant 1 over 4 outside the integral to make it cleaner. Volume equal 1 over 4 pi times the integral from 6 to 18 of y minus 2 dy. Let's find the integrals of each term. Term 1, y becomes 1 over 2y². Term 2, 2 becomes 2y. So our integral is volume equal 1 over 4 pi times the quantity, 1 over 2² minus 2y, to be evaluated between 6 and 18. Let's solve for our upper limit, 18. 1 over 2 times 18² minus 2 times 18. This is equal to 126. As for our lower limit, 6. 1 over 2 times 6² minus 2 times 6. This is equal to 6. Subtract the lower from the upper limit. 126 minus 6 equal 120. Finally, multiply by the constant outside, 1 over 4 pi. So 1 over 4 pi times 120 equals 30. So our final volume is 30 pi cubic units. Remember, when rotating around the y-axis, always solve for x² and use y boundaries. If this video helped you, hit that like button and subscribe for more calculus breakdowns. See you next time.